All right, we're going to do molecular structures for a few different molecules here. I'm going to use my extra paper to give myself a little bit more room. So we have the first one is going to be BrCl3. That ends up being 28 total valence electrons. You will tether the outer atoms like normal, and that will use 2, 4, 6 and leave you with 22 valence electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18. 18 leaves 4, and then this 4 just get dropped on the central atom, and now we've assigned all of the valence electrons. For the purposes now of doing the structures, we only care about the number of bonds to the central atom and then the number of lone pairs to the central atom. And there's one pair here, one pair here, and so we have 2 lone pairs and 3 bonds. That gets us into an electronic shape called trigonal bipyramidal. It's going to look like this. And we have to decide where to put the chlorines and then where to put the lone pairs. So chlorines will go into, these are called the axial positions, like the North Pole and South Pole if this were a globe. One chlorine will go over here, and then our lone pairs go into these sides. This is trigonal bipyramidal. Well, to get from this electronics geometry to the molecular geometry, it ends up that lone pairs are not visible, and so cover them up and redraw the structure, but do not move any of the atoms. Okay, just remove the lone pairs, and then this ends up being T-shaped. Okay, our next one here is CCl4. CCl4. That's 1 carbon for 4 electrons plus 4 chlorines. Gives me a total of 32 electrons to assign. Two, 4, 6, 8 leaves me with 24 electrons to assign. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24 electrons. And we've assigned all of our electrons now. So again, to get the actual structure, we only look at the bonds. We don't care about the lone pairs on the outer atoms. And so put the carbon in the middle, and this is a electron domain, four electron domain of 4, and so this gets a structure called tetrahedral. Since there are no lone pairs to cover, in any case where there's not any lone pairs on the central atom, then now our molecular structure is identical to our electronic structure, also tetrahedral. All right, we have SF4. So 1 sulfur, 4 fluorines, 28 and 6 gives me 34 valence electrons to assign. Sulfur's in the middle. I use up 8, and that leaves me with 26. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Leaves me with 2, and then without even thinking about it, I'm going to make them a different color even so you're aware they're on the central atom. The 2 here on the central atom, these 2 green ones, are my final. I dumped those on the central atom and now assigned all the electrons. From this, I'm going to go now, this is a domain of 5, 4 bonds and 1 lone pair. Sulfur, and this is also going to be, for a domain number of 5, it's a trigonal bipyramid. Fluorines are going to go on top and bottom, and then they'll go around like that. Okay, and this is a seesaw shape that it has. Oh, sorry. Trigonal bipyramidal. Cover up the lone pair. And now it becomes a seesaw shape. All right, last one of this set, SF6. So 1 sulfur plus 6 fluorines, 2. Now our numbers are getting big, 48 total electrons to assign. So I've assigned 12 of them, leaves me with 36. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. So I use all of them. Left over with, have no electrons left over at the end. And so this has a structure called octahedral. And since there's not any lone pairs on the central atom, the molecular structure itself is also octahedral.